Hello everyone and welcome to the second part of AWS Identity and Access Management. So role terms and concepts explained. First one, service role. A service role allows AWS services to perform actions on your behalf managed within IAM for creation, modification and deletion. Second type of role is EC2 instance role, a specific service role for applications on EC2 instances to perform actions in your account using temporary security credentials. Service linked role. This is the third type of role, a role linked to an AWS service, which allows it to act on your behalf. These roles are visible in your AWS account, but cannot be modified by IAM administrators. Role chaining. So this is a concept where this is the process of using a role to assume another role through AWS CLI or API, and this allows for complex permissions management. Delegation, and this is the process of granting permissions to access your resources to another AWS account involving a trust policy and a permissions policy. Federation and federated user, establishing a trust relationship with external identity providers for user access to AWS resources without creating an IAM user. Trust and permissions policy. Trust policy defines who can assume the role, while permission policy outlines the role's access capabilities. Permissions boundary, a feature to limit the maximum permissions a role can have, not applicable to service linked roles. Principal, so I already talked about it, but this is a bit related to this topic. So an entity which can be user, role or account in AWS that can perform actions and access resources defined in policies. Role for cross-account access, a role that enables access to resources across different AWS accounts, facilitating secure collaboration. So types of policies. So we'll go through all the types of policy. First one, identity-based policies. This gets attached to IAM identities to grant permissions directly to users, groups or roles. Second type of policy is resource-based policies. This gets attached to AWS resources like S3 buckets to grant permissions to any principal, including those from other accounts. Third type, permission boundaries. This is used to define the maximum permissions an IAM entity can have, acting as a limit rather than granting permissions. Organizations, service control policies, and this controls the maximum permissions for members of an AWS organization, limiting what entities within that AWS account can do. ACL's access control list. This is utilized to grant cross-account access without using JSON. It is distinct in not granting permissions within the same account. And last type is session policies. These limit permissions for sessions created with the AWS CLI or API, restricting the permissions of the assumed role or federated user. So first, I will go deeply into identity-based policies. So first, they are JSON permissions policy documents, and these documents specify what actions identities are user groups or roles, can execute within AWS. They define the actions allowed or denied and under which conditions these actions can be performed. Managed policies, so standalone policies that can be attached to multiple identities within AWS, providing flexibility and reuse. AWS managed policies, created and managed by AWS. These policies are designed to cover common use cases and scenarios. Customer managed policies. These are created by the user, offering finer control over the permissions and policies applied to identities. And inline policies. They are directly attached to a single identity, ensuring a one-to-one relationship and are deleted with the identity. Next type is resource-based policies in AWS. Again, they are JSON policy documents, and resource-based policies are JSON formats that control permissions directly on resources. So identity-based are user group, so they are directly based on identity, and resource is on the object, which is the resource. These are attached to resources like S3, EC2, etc. And these policies are directly attached to resources, defining who can access them and under what conditions. Specify principal permissions. They grant specific actions to principals on the attached resource. Enable cross-account access. So by specifying an account or IAM entities in another account as the principal, these policies facilitate cross-account resource access. Role trust policy for IAM roles. IAM roles use role trust policies as their resource-based policies to define who can assume the role. Requires trust and identity-based policies. So for IAM roles, a trust policy, which is the resource-based policy, and an identity-based policy must be attached to define and enable permissions. So it's like a both way, it's a two-way street. So both sides we need identity-based to basically what the subject can do, and resource, which is the object, what object will allow. So both must match, then only this chain will be formed. Third type we are discussing is IAM permission boundaries. Permission boundaries are used to define the upper limit of permissions that can be granted by policies attached to an IAM entity. So sets maximum permissions for IAM entity, and so this feature ensures that the entity cannot exceed the permissions defined in the boundary, regardless of the permissions specified in the attached identity-based policies. So it supersedes all other types of policies. So this is the maximum boundary. Requires both identity-based policy and permission boundaries agreement. An IAM entity can only perform actions allowed by both its permission boundaries and the identity-based policies attached to it. Not limited by resource-based policies. So permissions boundaries do not apply to resource-based policies that define the entity as a principal. So it applies only to the identity-based policies. Explicit deny overrides allow. So in IAM, an explicit deny in any policy will override permissions granted elsewhere, including within permissions boundaries. So this is in general. If there is a deny statement that explicit, it will override any kind of allow. So fourth type of policy is service control policies in AWS organizations, and this is specific to AWS organizations feature, meaning if you have an AWS account and that account is part of this AWS organizations feature, so most of the time enterprises use this feature. This comes handy when you have at least 2 AWS account and they form a AWS organization. So just quick overview, AWS organizations allow for the grouping and central management of your business AWS accounts, SCPs applications. So if all features are enabled in an organization, service control policies can be applied to any or all AWS accounts within it. This defines maximum permissions. So SCPs, again, service control policies, are JSON policies that set the maximum permissions for an organization or organizational unit. So limits permissions for member accounts. These policies limit the permissions for all entities in member accounts, including the AWS account root user. In the context of SCPs, any explicit deny within these policies will override permissions that are allowed. So same repeat theme, deny takes precedence. Understanding access control list, ACLs, in AWS. So this is the fifth type of policy. Access control list are policies controlling access to resources by principals from another account. So this is very specific. This comes into picture only if there are 2 AWS accounts involved. ACLs cannot control access for principals within the same account, only for those in different accounts. Unlike other policy types, ACLs do not use the JSON policy document format. Supported AWS services. So services like Amazon S3, AWS Web Application Firewall, and Amazon VPC utilize ACLs to manage access control. So 6th type of policy is session policies. Session policies are used to define permissions when creating temporary sessions for roles or federated users. These sessions are generated using API calls, and that allows for dynamic permission management. So basically, they are programmatically created sessions. Intersection of permissions. The effective permissions for a session are determined by both the identity-based policies of the IAM entity and any session policies applied. Again, explicit deny prioritization. Any explicit deny in any applicable policy will override permissions granted by others. API operations for session creation. Sessions can be created using assume role with SAML, or assume role with web identity operations. So these three are the three APIs: assume role with SAML, and assume role with web identity. Support for JSON inline and managed policies. So you can specify permissions using a single inline JSON document or up to 10 managed session policies. So I'll quickly go through JSON policy document structure. So first we have version. This specifies the version of the policy language that you want to use, and it is recommended to use the latest 2012 1017 version. So you can check out the documentation for exact versions. Next, statement. So use this main policy element as a container for the following elements. You can include more than one statement in a policy. So statement is one of the mandatory field. Then SID. So this is an optional. Include an optional statement ID. So SID is statement ID to differentiate between your statements. Effect. So there are two possibilities: allow or deny, to indicate whether the policy allows or denies access. Next, principle. Required only in some circumstances. So if you create a resource-based policy, you must indicate the account, user, role, or federated user to which you would like to allow or deny access. If you are creating an IAM permissions policy to attach to a user or role, you cannot include this element. The principle is implied as that user or role. Next, action. This includes a list of actions that the policy allows or denies. Resource. Required in only some circumstances. So if you create an IAM permissions policy, you must specify a list of resources to which the actions apply. If you create a resource-based policy, this element is optional. If you do not include this element, then the resource to which the action applies is the resource to which the policy is attached. Then we have condition, which is optional, specifies the circumstances under which the policy grants permission. So this, the example policy here, this example uses three distinct statements to define different sets of permissions within AWS account. So first statement, so this is, we have statement, this is an array, and this is again a JSON inline, not inline policy, but this is an array. There are three statements. And the first statement allows the user to change their own password irrespective of the resource specified as asterisk, because the change password action inherently applies only to the calling user. So automatically this applies to the whoever has called this, or whoever has called this statement, this policy. Second statement permits the user to list all S3 buckets within their AWS account. Access is confined to their account even with the star resource designation. So this is the AWS account. This is for the calling user. And the third statement grants the user permission to list and retrieve objects from a specified bucket named confidential data. So here we are saying resource. So here we are saying resource here because the whoever has called, so that calling user, but here we are saying these two buckets, top level metadata and whatever is inside is allowed access. So access under the third statement is conditional and requires the user to be authenticated using multi-factor authentication. So only if multi-factor authentication is true, this access will be given. A condition element within the policy statement makes the statement effective only when the specified condition evaluates to true. So this must be evaluated to true for this whole thing to be allowed. If the user is not MFA authenticated, the condition in the third statement is false and access to this particular bucket confidential data is denied. And this is very specific syntax like we have to give for a bucket. First we have to mention the bucket and then we have to say /* for everything inside it. And the following identity based policy allows the implied principal, so whoever is the calling like a role, user or group, to list a single Amazon S3 bucket named example bucket. And this particular policy is a resource based policy, can be attached to an Amazon S3 bucket. The policy allows members of a specific AWS account, so this is the account ID, to perform any Amazon S3 actions in the bucket named my bucket. It allows any action that can be performed on a bucket or the objects within it. Because the policy grants trust only to the account, individual users in the account must still be granted permissions for the specified Amazon S3 actions. So this is the action like what they can do. So here we are saying they can do all kind of actions like get, list, describe, put, fetch, all kind of S3 actions. Next topic is granting least privilege in IAM policies. So principle of least privilege. So this emphasizes granting only the permissions necessary for a user or role to perform their tasks, enhancing security. So I'm just talking about one of the best practices when it comes to IAM. Specific task permissions. Analyze the tasks users and roles need to accomplish and tailor policies to those specific needs. Start with minimum permissions, so you can begin with the least amount of access and incrementally add permissions to avoid excessive access rights. Adjust permissions as needed. Dynamically update policies to grant additional permissions as tasks and responsibilities evolve. So some alternatives. So AWS managed policies. For initial setups, AWS managed policies or wildcard permissions can provide broad access to be refined over time. So AWS managed policy, they're like a huge number which you can go and check out for almost all AWS resources. So they have variation like read, full access, or write, or contributor, and you can use them and then fine tune them by creating custom versions as per your business requirements. So refining IAM permission strategy. So understanding access level groupings. So utilize access level groupings to comprehend the extent of access a policy grants, categorized under list, read, write, permissions management, or tagging. The next step is validate your policies. Employ IAM access analyzer. So this is a feature where it will, based on the existing data, it will give you the access analysis for policy validation to ensure policies are secure and not overly permissive, utilizing over 100 policy checks. Generate a policy based on access activity. So leverage IAM access analyzer to create policies based on actual access activity, and this allows for more permission, for more precise permission grants based on the CloudTrail logs. Use last access information. So access the Access Advisor tab or AWS CLI API for last access data. So this is information is already being captured to identify and remove unnecessary permissions, further aligning with principles of least privilege. Review account events in AWS CloudTrail. So you can inspect CloudTrail event history for detailed actions and resources accessed by IAM entities to fine-tune permissions accordingly. So this diagram illustrates AWS managed policies. The diagram shows 3 AWS managed policies: administrator access, power user access, and AWS CloudTrail read-only access. Notice that a single AWS managed policy can be attached to principal entities in different AWS accounts and to different principal entities in a single AWS account. This diagram illustrates customer managed policies. Each policy is an entity in IAM with its own Amazon resource name ARN that includes the policy name. Notice that the same policy can be attached to multiple principal entities. For example, the same DynamoDB Books app policy is attached to 2 different IAM roles. This diagram illustrates inline policies. Each policy is an inherent part of the user, group, or role. Notice that the two roles include the same policy, the DynamoDB Books app policy, but they are not sharing a single policy. Each role has its own copy of the policy. So some security best practices in IAM: federation with identity providers. So you can advocate for human users to access AWS with temporary credentials via identity federation, enhancing security. Second best practice: use of temporary credentials. Encourage workloads to utilize temporary credentials with IAM roles for AWS access. This helps improving your security posture. Require MFA and force multi-factor authentication for an additional layer of security. Update access keys. Regularly update access keys, especially for scenarios necessitating that requires long-term credentials to mitigate risks. Protect root user credentials. Emphasize the importance of safeguarding root user credentials against unauthorized access. Apply least privilege permissions. So implement permissions that provide only the necessary access rights to perform a function. Start with AWS managed policy. Begin with AWS managed policy, progressively moving towards custom policies that adhere to least privilege principles. Use IAM Access Analyzer. Employ IAM Access Analyzer to create policies that ensure minimal privilege based on actual access activity. Review and remove unused assets. Regularly audit and eliminate unused users, roles, permissions, policies, and credentials to minimize security vulnerabilities. Use conditions in policies. Incorporate conditions in IAM policies to tightly control access. Verify public and cross-account access. Use IAM Access Analyzer to check for public and cross-account access to resources, ensuring appropriate access control. Validate IAM policies. Utilize IAM Access Analyzer to confirm that IAM policies are secure and operational. Establish permissions guardrails. Set up guardrails across multiple AWS accounts to maintain a consistent security posture. Use permissions boundaries. Implement permissions boundaries to delegate permission management within an AWS account effectively. Root user best practices for AWS. First one, secure root user credentials. Prevent unauthorized use by safeguarding your root user credentials. So make sure it's like safely kept in a vault or something. Use strong password. Enhance protection by using a strong complex password. Secure sign-in with MFA. So add extra layer of security by making sure you enable MFA. Avoid root user access keys. So reduce risk by not creating access keys. So access keys are used for programmatic access. So better not to create access key itself so that nobody can use it. Multi-person approval for sign-in. Enhance security by requiring approval from multiple persons for root user sign-in. Use group email for credentials. So use a group email address to manage root user credentials, ensuring shared responsibility. Restrict access to recovery mechanisms. So tighten security by restricting access to account recovery options. So usually hacker will use this to basically hijack your account. So restrict access to recovery. Secure organizations account credentials. Safeguard your organization's accounts root user credentials. Monitor access and usage. Keep track of root user access and usage to identify unauthorized activity. And some tasks which require AWS root user credentials that we need to be aware of. First one, change account settings. So only the root user can alter key account settings such as the account name, the email address which you have registered with, password and access keys. Restore IAM user permissions. If an IAM admin loses their permissions, root user login is required to restore access. Activate IAM access to billing and cost management, and this is essential for monitoring and managing AWS expenses and usage. View certain text invoices. So root user credentials are needed to view specific tax invoices, particularly for value-added tax in AWS Europe. Close AWS account. So terminating your AWS account must be done by the root user to ensure security and data integrity. And register as a seller in the reserved instance marketplace. This task is reserved for the root user to manage AWS resources selling. Configure S3 bucket for MFA. Enhances security by requiring MFA for critical actions on S3 buckets. So this also needs AWS root user. Edit, delete SQS resource policies. Root user can modify or remove SQS policies that deny all principals for security reasons. Edit, delete S3 bucket policy. So similar to SQS, root user intervention is necessary for policies denying all principals in S3 buckets. Sign up for AWS GovCloud only in US. So exclusive access for root users to enroll in AWS services for US government and affiliates. Request GovCloud root user access keys can be done only by the root user through the AWS support for secure access. Recover AWS KMS key, key management service key. In case of an AWS key management service key becomes unmanageable, the root user action is required for recovery. And that's all. Thanks for watching.